All right, I'm going to make a video about why I think the natural number e is so important. Well, it's not just why I think, it's why the natural number e is important. I'm not going to say that there aren't other reasons, of course, but this is one of the key ideas why the natural number e is important in calculus and in the natural sciences, I guess. All right, and just to let you know, if you're watching this video, this will be the bonus on the next test. So that's a nice little bonus that you're getting for watching this video. If you want to share that information with others, you're welcome to, or keep it to yourself. I don't care. But the bonus will be about this topic, if I remember. I'll try to do that. All right, so there's something special about the function e to the x. And that's why it's important in the natural sciences. I'm going to open up a file to try to demonstrate. So here I have the e to the x function graphed right there. And I have a line plotted that is tangent to the curve. Now in geometry, you guys talked about what it means to be tangent to a circle. And a tangent line to a circle just means it touches at one spot and only one spot. Well, that's kind of what a tangent line is as well. As you can see, this line touches the exponential function at just one spot. So this measure right here is the slope of this line. So as you can see, as I trace this exponential function in different spots, it changes the slope. Here the slope goes to 0. Here it's equal to 1, and then it kind of increases. So the special property of the exponential function is if I were to take this point that is on the function, the point of tangency, and measure the y coordinate. As you can see, like when it's right here, the y coordinate is 3.4. If I move it down to here, it's equal to 3. If I move it to here, it's equal to 2. So this is basically the function value of my function e to the x. But as you can perhaps see, the slope of the tangent line is exactly the same as the y coordinate of the function. And that may seem kind of like a trivial or not a very important observation, but that's why the natural number e is so important. What it basically says is that the slope of the tangent is, or how steep the curve is, how steep this tangent line is telling you the rate at which the function y equals e to the x is changing. So the rate of change, the rate that this function is increasing, is exactly equal to its function value. Well, in the natural sciences, a population is going to grow. A population's growth rate is going to be proportional to the population's size. So this y coordinate is like the population size, and this slope is like the growth rate. So this function, whose y value is exactly the same as its rate of increase, this exponential function is the only function that has that property. Actually, there's one other trivial function, plot a new function, y equals 0. This one also has, it's kind of not very interesting because the tangent to a horizontal line is always a horizontal line whose slope is 0. So its function value is 0 and its slope is 0, but that's not very interesting. Whereas this function is. Now, if I were to change this to any other base, it wouldn't work. Actually, my geometry is going to break down if I do that. But if I were to change it to base 2 or base whatever, the slope of the tangent line would not be equal to the function value. And if you pick any other function, x squared, sine of x, no function will have that property except for this function here. So that's why the natural number e is important. Thank you.